know me, my name is Steve Firsake, and um, I'm going to give you just an overview of what Google Earth Engine is, how it entails, what kind of things to expect when you deal with it. Later on, if we pick, like, let's say if we pick a different time, we can actually go down to coding directly. Although in the material that I've provided, it has links. I still think it still has the links that you used to have on him. Confirm. Let me confirm. They share the links. Okay. I know what I'll show you guys. So what's Google Earth Engine? Google Earth Engine beats the purpose of having ArcGIS or having QGIS, especially when you want to churn a lot of data within a very short time. And nowadays, as you can see, that most of our tasks, the tasks that we are doing, we are starting to deal with very wide areas. For example, if somebody wants to monitor floods, then that person has to observe a very large region. Like there's a time I did for Beira region in Mozambique when there was a flood. When it had flooded after the hurricane. I don't remember what's the name of that. It was called Hurricane what? Is it a tornado or a hurricane? There's something that happened in the ocean. Then after that, people had to monitor all those types of things. So it was easy to do that on Google Earth Engine because it has a cache of most of the freely available data sets that is provided. So you'll find Landsat, Sentinel, and other different, I think somebody's trying to join. And other data sets. Let me just .google.com. Okay, I've opened it on this browser. Nope. Code.google. Simeandika hivi hata. Code.earthengine.google.com. So as I was explaining earlier, when you want to churn a lot of data quickly over any part of the planet, on different data sets that are freely available, or alternatively, if you have some mega project, let's assume you have your own images, like you have high resolution imagery that is very heavy for you to work on within your computer, you can always push to Google Earth Engine and then do your processing from the other side. And as a plus, the Google team has done a lot of work to provide all kinds of algorithms that are being published on papers currently, or the algorithms that we are comfortable in using within software like QGIS or ArcGIS. All these things are there. And the good thing is that you can experiment very many things on Google Earth Engine. You can tweak those algorithms to see what different types of outcomes you can get. For example, for a long time, I always thought that averaging, that we have to do mean when we want to study some place. Let's say, for example, I want to get I want to look at the outcome of what happened in Kisumu County for the past month. Long time ago, I used to do mean. Then I realized with Google Earth Engine they also have Median, and Median gives you a much better outlook. Think of you know what all of you guys know what Median is. In Median, if there are very many pixels on a specific point, you are going to pick the one with the middle value, meaning that you will have removed whatever error there was. Let's say, for example, if there was cloud cover, clouds will not cover a place for a very, like they will not cover one region at the same time of the day for every single day on that month, maybe. So clouds would be extreme. Let me see somebody's. Clouds would be on the extreme side. So I learned how to do medium using Google Earth Engine. It's easier to experiment with such kind of things and look at. Okay, let's admit this guy. Welcome. Let's see, we have quorum now. Yeah. So let me continue. Okay, so let's dig right into it. So I mentioned, let me show you this. If all of you have opened this link, if you could all open this link, that depends. You have to sign up for, if you've never used Google Earth Engine before, you have to sign up for it. But access is freely available to everyone. So I want to show you something. So up on here, this bar, let me hover my mouse. Here where I'm hovering my mouse over, you will find all kinds of data sets. Let's say, for example, I don't know whether JAXA is there, whether they have JAXA data now. I think this is JAXA data. Yeah. If you want JAXA data, you see all this data set is available. Let's say you want Landsat. As you can see out here, all the collections that are available from USGS are available through Google Earth Engine. You don't need to download things anymore. You just go and pick the specific imagery that you needed to use. So for something that I can advise people, a little bit of remote sensing on your background is actually required. You have to know, like, let's say, for example, the one that I'm hovering over is Landsat 7 collection, 1 tier 1 real-time data raw scenes. You have to know what's the difference between this one, what is tier 1 and tier 2s. Let me see whether they removed the tier 2. There are tier 2s that are still around. That's just different levels of processing of the product before it was released. Further processing has been done for tier 2. But not it's not that much. But you have to know a little knowledge in remote sensing is very important when you want to do most things on Google Earth Engine. And so something that you have to know, Google Earth Engine works very good for the real power of Google Earth Engine is in remote sensing. If you want to do GIS work, on Google Earth Engine, yes, you can. You can display layers, you can show different things, but they did not really. Let's say there's a bit of tweaking that you have to do to actually work with to do GIS work. So if you might prefer other software if you want to show, but then you can save data on Google Earth Engine and access it on your platforms, on your separate platforms. So as I was saying, here you get all the data sets through that. And then on the left, you can see a panel that has 3 tabs: scripts, documents, and assets. Scripts is where you write your, okay, somebody's joining. Script is where your scripts reside in. This is where you save them. You can create a folder. You can create a repository. Like, okay, you as usual come the first time you use Google Earth Engine, you have a default repository. As you can see, this is mine. This Steve Firsake default is mine. I have important modules. That is for some side projects, or it allows for you can create a module and then import or require ones the same way we do with different in different programming languages. You can also write your own. You can write your own module and import into a different script. Yeah, so these are just some of my repositories. And then the most important one, which I want to show you, the most important thing which most people, when they get to Google Earth Engine, don't always realize is this part here. You can see something written, examples. I hope you can all see that. If you have code editor open. So under examples, this is where you find the most fascinating thing. Every single time the team back at Google make any changes to the code to any part, like let's say, for example, when they deprecate something, then users have to know that something new has come out. They always put everything here in the examples. And in the examples, you'll find short code references for all types of things that you will want to do within Google Earth Engine. For example, let me pick one here. Let me see which one. Okay, land cover cleanup. You see, they have written all kinds of code that are associated with doing a specific task, and they have comments that are inside. So let's say, for example, you might be okay. Here they say land cover cleanup. Let's see what this is. Project focal mode, focal max. Let's see. Yeah. See that? Yes. As you can see, whenever they do something, they are using. Okay, you'll find very insightful. You'll find the things that you can do with Earth Engine is very insightful. For example, just look at this comment that has been made here above line. Okay, at line 22. Using erosion and dilation to get rid of small islands. Now that is something if you try to run, like if you try to go and achieve the same thing using ArcGIS, you would not find, you'd have to write some very long code to go and achieve something just as simple as this. Focal maximum, focal minimum. What do these ones do? You can check. So remember, the most important part is here, examples. Always remember that every single time you use Google Earth Engine. Some of the things that you might want to go and ask people are already here. For example, somebody would ask, how do I do cloud masking? Cloud masking, all of them are here. You can see under cloud masking, how to cloud mask Landsat 4, 5, and 7, surface reflectance product, how to cloud mask Landsat 8 surface reflectance, how to do the same for Landsat 8 top of atmosphere reflectors that has a quality band. Some of this, when you read into, when you find out more about remote sensing and why these data sets are the way they are, then you would understand some of these things. So you can see like this one, this code has produced this. I'm not really sure what this person really wanted to achieve. Let's see what's the top layer, the smoothed one. And why did they write them like that? I can save this. You see the way I open this thing from the examples. Any changes you make to this code, let's say for example, you can see the word wetlands. Oh, and this is JavaScript, by the way. For those who might not know, but most of you, I know you come from programming backgrounds. Yeah, so this is JavaScript. So you notice up here, there's get link, save, run, reset, and apps. So save is not active. But if I add any changes, if I make any edits to this code, like for example, I've added a space, you can see now I can save this script to my own script, to my own repository, to any of my repositories. Okay, let me show you something. Let me show you. Okay, cloud masking this, abandon changes. So this function, I have used this function in most of my code. I think I should even just make it into a module. Yeah, that's one of the projects that I'm doing currently. I should just make this into a module and add some other things. I make them into modules. So you can see this function, as small as it is, it's taking, okay, like from here, okay, we'll get to see much more of these codes, but this function, this tiny function here, takes in that image and cloud masks. Let's see for which region this one's doing it, or they're doing it for the whole world. Yeah, this is going to do for the whole world. Let me pick a tiny place. Let me pick Kisumu. Whether I usually reduce my brightness. So you can see, this is for which period of time? For the whole of 2016. We've picked images for the whole of 2016 and then cloud masked them. So this is a bunch of images. These are composite, yeah. And then we are doing a median. So we picked all the images for the whole world for Landsat 8 for the year 2016. And then we did a median on them, and you can see how clear this looks like. If we did a mean, whenever you do an average, you have to remember something in statistics, that outliers affect mean. Let's assume you have an extreme. There's a performance. There's some class sat for some exam. Then the first person got 100%, and then the second person got 70%, and then the last person got 12%. And very many people are concentrated around 50%. If you do a mean for that class, because of the person who got 100% and 12% who are outliers, they will affect their marks affect the mean. They have an effect of skewing the mean from what's supposed to be normal, from the normal. Yeah. So that's why median is actually a best bet. You can see how clear this looks like. And I only ran this just directly from the examples that were out here. So then how do you know about the different segments of this code? Okay, before I get, okay, let me just show you. So you see, this was scripts where we had our repositories, and then I showed you the examples part. Then, okay, so a reader, okay, then let me explain these other two things. A writer is when we coordinate in, let's say, for example, you can see like these three repositories. Somebody shared them with me. They have the rights to edit, and I can also edit at the same time when we're working on the same project. Or if I'm creating a module which is going to be accessible by someone else, they can share their repository. Reader, these are repositories that I can pull from people, but I do not have. I cannot save them. I can't write anything to them. I can only read them. Yeah. And then up here you can see a tab called docs. The docs is where you have the cache of all the code, all the unique code that has been created by the Google team. Let's say, for example, you can see here median working on an image collection. So under here you can see image collection, and you can see all the arguments that you can add with image collection. For example, filter date. It's up here somewhere. Yeah, there's filter date, there's filter bounds. You can filter by metadata. You can also create a unique filter. Let's say, for example, you can filter values greater than or less than, yeah, stuff like that. So that is under docs. Under docs, you'll find all the code that is supposed to be, all the code that is used along it, all the unique code that is used for processing data within Google Earth Engine. Yeah. And then some of them, okay, see like this one, you see this one is the way they have made it red. This has been deprecated. They want people to use a different one. And then to make things faster, they have to make processing very fast. Let's say, for example, let me explain like this one here, map. Usually, if I was writing code in a different language, and I wanted to do something in a loop, like I wanted to do something iteratively over some data, I would create a for loop, and or whatever type of loop somebody would create. But the problem with that is at times you're dealing with so much data sets. So the team at Google, what they did was they sat down and then they thought about different ways of churning their data. So they have stuff like map. What this map does here is it loops through every single image that is inside this image collection and passes it here. So you can see this function takes an image, yet you passed an image collection through it. I'm going to explain what an image collection is soon. Let's just continue first looking at this tool first. Just give you an overview of the different parts. And then we have assets. You can see as the third tab, assets. Assets is where you can import your own data sets. Like for example, shapefiles. I don't know whether they have different, okay, they still do shapefiles. They haven't gone to GeoPackages. But you can see, you can upload a shapefile, you can upload a CSV, you can upload an image collection. So I think then I have to explain what an image collection is. What we are used to is just single images. Like let's say, for example, a scene from a certain time. That's just one image. That's just an image. But when you assume that all these images have been tiled, think of them like pages in a book or as a deck of cards. When you have a deck of cards and all the different cards are images, that's what we call an image collection. So it's like almost something like a net CDF for those who have dealt with the HD5s. Yeah. So that's how they stack up. And then so the assets is where you import data. Like you can see on here, I have some training sets, some training data that I was using with machine learning, with some neural network within Google Earth Engine. And then let's see, this is the code. This is the code region where you write your code. Get link is when you want to share your code with someone. Like let's say, for example, like this one, the one that I've copied. I can share it with everyone within there. I can share it on the chat. What did I choose which layer? Okay, I'm going to get back to your question just right now, Wycliffe. Okay. Let me first show you. We are coming to that. Then, okay, this is the code area. Get link is to share a link for the code that you're writing. Run is to execute. When you want to execute your code, it's run. Reset is to clear. You can clear the map itself. Let me see something else. Or clear this part. I'm going to explain what this part is. So for apps, I don't know whether mine are still available. Yeah, I knew. I refused to pay Google. Can you imagine? Usually, long time ago, when Google Earth Engine started, all resources were free. Then there's a time when a guy called Noel Golerick visited us at RCMRD and is one of the software engineers that built Google Earth Engine. So I asked them, why is it that we can only write code and just get data sets, but some of us would want to create fancy looking apps or applications. Yeah, we would want to create an application where someone can have it as a standalone. Let me show you one that is not a standalone. There's let me show you what I meant. Satellite Explorer loaded. There's this app I created that enables me to download any kind of data or to classify data and stuff. I built this because I'm a very lazy person, and at times somebody gives me a task to go and do over some region, and it's usually repetitive. So I created this. So inside my code, all of you are programmers and you understand how these things work. So when I have data set, like let's say, for example, let me show you something at the top here, something interesting. You can see on here, I have countries. There's some data set. There's a data set for countries. Let's see, countries. Yeah, this one. LSI, this large scale boundaries. It has all the boundaries, all the countries on the entire planet. And Kenyan counties is just a shapefile that I uploaded. So as you can see here, it's under users, Firsake, Kenya counties. This one is under my assets. You'll see, let me see where I have it at, Kenyan counties, Kenya counties here. So what I did was just click on that and imported it into script. That. I can remove it. Okay. So as you can see out here, how do I access, like let's say if it's a place like Kisumu, as you can see up here. If I want to access Kisumu, all I have to do is just filter out Kisumu based on this property, as you can see here. So this is a Google Earth Engine command. Filter something that is equal to. Let me show you what I mean. You can see here ee.filter. E is the extension for Earth Engine objects. Filter is an Earth Engine object. And then under it, there's a method called equal to, EQ here. You can see what it does. Filter to metadata equal to the given value. There's other things you can filter against. There are so many filter things that you can do. Yeah. So you can see now I can access, if I want to access Kisumu, all I have to do is just change this part. If I want to access any other place, I just need to know how it appears, how it has been saved within my shapefile, the name that it is, the name that it has. Yeah, so this is supposed to be, you see, now it's an app I built, but it is not standalone. It is under my code editor. Let me show you, for example, I think there's something I was investigating. Let's say I want, let me pick monthly, but I can also do seasonal. So for example, if somebody wants to look at, let's say the planting season, or somebody is trying to look at the dry season of some region, I have, okay, you guys understand it. It's just, I try to see what I can do with Earth Engine, and from it, I can pick different dates, or I can pick a month. So I can do annual aggregation, I can do monthly aggregation, I can do seasonal aggregation. And remember, in all of them, what I like to use is medium. But there's something else, and I'm going to show you just right now. So this is not a standalone application. But now up here on apps, you see they are warning me. Yes, I've not associated them with any. Long time ago, I could actually do this. I don't know whether they will. I think these guys, the way they have done this, I know what they want me to do. Long time ago, before Google realized that there were very many people that are going to join and use Google Earth Engine for very innovative things. Some very big discoveries have been made just by people playing around with Google Earth Engine. For example, there's once we were in a hackathon, and somebody used Google Earth Engine to detect missing vehicles that are in shallow waters, and it worked. Actually, the system actually worked. And then there's another professor that had to go and discard all the books that he had written about rivers, because with Google Earth Engine, you can actually simulate. You can make an animation, a video animation over some place. Like very soon, I'm going to do one over Kisumu, and any town. I'll share the code so that you guys can just tweak and do a video animation over any area, finding out how urban how they've been spreading out, how the town has been spreading out over time. Yeah. So Landsat 8, I haven't added to 2021. I think I need to do that. I usually update these things. It's the highest number. So you can see my slider, I start from 1970. Because up here I have all kinds of data set. Let me just see. Save that, and then I run it again. It's taking time. Okay, there it is. I have run it twice. So as I was explaining, so apps, you can build an app and have it independent of the code editor. So that's what they introduced this. So when Noel Gollery came, I told them that they need to do that. That's when they built this functionality, but they trapped me in it. They trapped me. I was amongst one of the first people to actually build these apps on Google Earth Engine. Then everyone started doing that and hosting them. Then they made sure that all of them have to now be linked with a Google Cloud account, which is supposed to be free. Actually, when you sign up, I was just not a fan of using my credit card and things, which is something that I should actually do to revive all of this. Okay, so I showed you what an app looks like. I think I should run this again. Why run it? No, I haven't run it. Then I'll show you what this is. So the panel to the panel that is on the farthest right. Let me just minimize this. This panel here. Let me just select something, then show you. I'll pick 2018. Pick a monthly, and I select the month of when does it look dry. February. February is usually a dry time. Okay, cloud threshold, let me leave it at 50%. Median, I love median. So, okay, I want to tell you something else. So there's median, which you know what it does, then percentiles. You remember when you talk about the first quarter, Q1, I think you guys know about that. Percentiles. Somebody's joining us. Let's see. Yeah, so there's median and percentiles. So what percentiles does is it will cut off values that are below. Like now, for my purpose here, for percentile 25, I cut all pixels. It will remove pixels that fall. It will only accept pixels that are within 75% of the range of the entire data set. Okay, median only picks. No, it cuts at the 75% mark, while median takes the most middle value. It's Q2. So this is like Q3, and then this is Q2. For those who've done statistics. Then, okay, I don't want to classify. Let me just run it. That. I don't want to classify it. Yeah, so there was nothing. That image was Apatana. Apatana is the side of Mount Kenya. Hapa kutakuwaga na clouds mingi sana. Let me pick a different place, different town. Maybe Kisumu. Apatana inakuwaga na shida.
So Steve, on this one, on this your code, it also does cloud masking, right?
Yeah, I
Okay.
have that. I have you can see all these properties. Let me just show you by something.
Okay, yeah, sure.
You see, I have all these data sets. All these data sets are accessible by my script. So for each of them, I have you remember where I showed you that under examples.
Yeah,
You remember I showed you under examples, there's all these kinds of examples. There's all
yeah,
these,
sure.
yeah. So I have these functions within the script.
Okay.
That's how I don't need to put them in this script directly. What I want to do is I want to make them into like let me show you one. Let me just show you I've required something. Require. You see like this one, Mosaica.
Yeah,
When I want to pick, let's assume I want to pick data for a specific day. Assuming that I know the specific day that the satellite made a pass. So I have this as a module that is separate, mosaic by date module. So this is what enables me to do that. So also for this, I think I need to do the same for cloud masking. Or here they are. So you see this function, this one does for Landsat 8 surface reflectance value, Sentinel-2, Landsat 7, 5, and 4. Sentinel-2 when it's only a single image. Landsat 8 when it's only a single image. Sentinel-2 when it's only a single image for the daily. Yeah, I think why do I have two of them? Okay, I'll figure out. But one of them, let me just see what this does. The daily product, that is the newest code that I wrote. Okay. Yeah, so I stopped using the other one. Then I need to remove it completely. Okay.
yeah, it's okay. Actually, there's something that I was doing. That's what made me curious because I'm doing something about this too. But I'm also trying to do like a time series. So
Yeah,
what
you
you are,
can.
yeah. So what you are thinking about is where there is gaps of cloud. I don't know if Google Earth Engine has got this, but does it have like special interpolation methods? Maybe one can try to
To
predict
fill.
where there are cloud masks and to fill the image.
The best. You see, like here right now, this is Landsat 8. Landsat 8 only has like 2 passes in a month. So when I do a median, I'm only doing a median for 2 images.
Oh,
But if I
okay.
had made it, let's say, for example, annual for the same region,
Yeah,
if I made
annually,
it,
yeah, it will have covered most of it actually.
yeah, it will
Yeah,
remove. Yeah,
because it's more images and
yeah.
yeah. Okay.
So you can see now.
Yeah.
So if I wanted to do, let's say, for example, if my project was not is not seasonal based, or if my project does not, if my project is not sensitive with certain things like clouds, like what, let's say, for example, um, I wanted to look at the spread of something, let's something permanent. Like let's say, for example, if I did the same thing over town, it
Yeah.
will cut out all the new buildings, but then it will show me all the buildings that were permanent in one place. Like
Yeah.
if I'm looking, let's say for example, I want to pick when I'm picking, I want to pick training data, and then I have a class called urban, the urban class. For me to get very nice training points or to add very good training points, I would just do this over that region, and then I look at what has remained permanent. As you can see here, Mount Kenya is permanent.
Yeah.
Mount Kenya is permanent, and anything that existed throughout the year 2018 will also appear on this image. Yeah, so that's how you can play with it. But there's also there are people, as a takeaway, what they usually do is they stitch images. I've seen people who do that. They stitch. Like let's say I've noticed that especially people who ask me mostly about classification problems. My 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 okay, the way I do things, the way I've done things, and the way it's acceptable. Let's say, for example, someone tells you have to do a 5-year classification of some region, but then you miss out data on, let's say, 1990. You don't have data for 1990. What I usually say is you can go to the next year, or you can go to the year that is before. You don't really need to. If you are missing something completely, you can go to a year that was just next to it, because there won't be very much changes for the same region over a year when you're doing something like classification. Yeah. So.
Okay, thanks. Yeah,
But we can side chat if you want. There are people who have created better methods. There are people who have done better algorithms on Google Earth Engine for cloud masking. They are like, it's experimental. There are people like you see here we are just using the quality band, the pixel quality band to mask out clouds. But there are people who have different algorithms to actually do that. Yeah. So I wanted to show you guys what inspector is. So inspector, when I just click on a place, let's say I've clicked on that point, it gives you this information, the coordinates of the place where you've clicked, and then for the image itself, the point where I clicked on the image, these are the band values. As you can see here, these are the band values of the bands that I select for of the bands that I usually use. There are bands that we don't usually. And that's something as a takeaway if you're a remote sensing person. If notice that files are usually very big. Files are usually very big to download. That's why you have to do processing and whatnot and all that. So within Google Earth Engine, you can also filter out when you want to download. You can only filter out the bands that are most important to you. If somebody is going to if you want to go and deal with something in vegetation, only pick. You'll pick near infrared. You'll pick the red band. Let's see which other band do you need. I have them listed here. There's a website that enabled me to write all these band combinations. So you see, okay, let's see. Let's look at. I've seen them down there. Do I have? Okay, so I've explained them. Okay, so you can see them here. So these are different band combinations. Let me just run it. Let me just run that part. Let me see, enhancement. No. Yeah, so these are different band combinations. Let's say if I was looking at, so right now we are viewing this image under natural color. Let's assume we wanted to look at, let's see what's false color for the same time. So you can only select which bands you want to download your image for, depending on the task you want to do. So like this is false color composite. There's a website, I don't know whether, this. Let me share it to you guys. There's this website that enabled me to know the different band combinations and for the specific things that somebody wants to go and do. Let's do that. Okay, Yes, Hosea. They are reducers. I would come. Okay, first let us look at the code editor. Then I'm coming to that because all of that is within the presentation that I'd shared. So I was showing you that the inspector part is where if you click, it shows you. It gives you information about the region that you clicked. So, for example, let's say you want to display an image within certain ranges. Let's say, for example, you can see here, like band. You can see the ranges of this band. Let's assume I was only interested in this within this band. This number is very small. I would multiply it by 1,000, maybe that band. I would multiply the whole image by 1,000, and then specify I only want pixel values between this minimum and that maximum when I want to display it at the end. Yeah. So that's where this clicking part usually helps. Okay, for my case. And then the console is where you will see error messages. You can see error messages, and you can also print out stuff, as you can see here. When my code, whenever it's where I log. It's where you can log things out, and also test things. Let's say, for example, you wrote some code, try to run it, nothing happened. You can print out objects. I can print out an object to find out whether it's an image or it's an image collection. So you can check things here. Then tasks. Whenever we want to download, like, let's say, for example, let's assume I was interested in this image for 2018 for Tana. and I want to download. I want to export the current image to Drive. This fires up a task for downloading. Then I can click it. Click it, and then specify what drive I wanted to do. Like if I have my own drive, I wanted to go to my own drive. Do I have a folder called that? Yeah, I think I had a folder called that. So I can either leave it blank so that this image is sent to my drive, to my Google Drive. Yeah, so what happens when you click on task? This is something else that you guys have to remember. Okay, wait. What have I added to it? They've changed these things. They do not want the task to contain. Yeah. I don't have any space anywhere. Oh, I've seen that Apatana. Oh, why does it say that? I didn't change the word Kisumu somewhere. Okay. Oh, this is Apatana. Remove that part. Run. So something users have to remember, this affects most people. Sometimes you don't usually know when your download has completed. So what I usually do as a takeaway is I usually keep on clicking on that question mark, looking at the status. I see whether it has finished, and then when you click on it, when it finishes, sometimes this thing, you see the icon, the spinning icon, the spinning Google Earth Engine icon. This spinning Google Earth Engine icon, okay, I don't know whether they fixed that problem, but long time ago, this thing could run for days. And you don't know that maybe your download already finished, or your download crashed, or your Google Drive space has been depleted. But then it just turns and does not inform you of anything. So what you usually do is, because you see, okay, yes, we can see something called refresh here, but let me tell you something about refresh. When you click it once, there's no more refresh. So what the trick is to click on this. Keep on clicking on this question mark at times. It helps. So that was just showing you this platform. So now we can go back to, we can get into this. So I've shown you all these different parts. The first lessons, the first classes that I usually sit people through are programming ones. I'll show you. Yeah, we usually do introduction to JavaScript, but I'm guessing, okay, depends. If there's a need, I don't know, Brian.
Yes.
Is there a need to go through JavaScript really?
No, not actually, because we had covered JavaScript previously. If someone had missed on it, it was uploaded.
Yeah.
Actually, Jordan from Microsoft covered it.
Covered JavaScript.
Yeah.
Okay.
We covered it late last year.
Okay.
Yeah.
So now I want to talk about the data set, but this we can have a different session where we can actually go through coding.
Yeah,
we can have like
definitely.
a set of exercises and stuff that people can actually do and then try and see those things. But the best thing that I can tell everyone is that this segment is your friend. Let me just show you. This segment down here where you have the examples, this is your friend. This is your very good friend. Let me show you another good friend. I think it's still under here. You can see where I've clicked under user guide. The user guide will help you very much because that's where they have all kinds of codes explained and what they usually do. So under this, you go to guides. And out here, you can see all these things, getting started, best practices. So, okay, I explained to you about the best practices. The best practices is because the team from Google have algorithms that run on their servers. So if you want to, they're trying to make processing work faster. So they have ways of doing things. For example, they will tell you not to use a for loop. I know it is JavaScript, but they will tell you that it is better not to use one. Nowadays I employ that in my code, but long time ago I did not used to do that. Yeah, but when you want to deal with so much data, so that you don't find memory issues, remember you're sharing the same platform with the rest of the world. So if you don't want to run into memory issues, it's good to use their best practices. And then, as you can see on down here, these are different tools. Okay, this is the main classes for just showing teaching you about JavaScript and how to work with it. Then you have the machine learning section. Excuse me. Then you have the machine learning session. This is not connecting. What's happening? Excuse me a little. Excuse me. Okay. Yeah, then you have the machine learning section with different codes and instructions on how to achieve machine learning within Google Earth Engine. And then the images and all different things that you can do with images. For example, visualization, which is the first thing that we're going to do. The first thing that was under the presentation at this point. Yeah, how to display an image. So remember that these guides, these two things, the examples part and the user guides are going to be your friend. Actually, they show you if you don't have if you don't have a strong remote sensing background, you can come here and first get to understand what is happening first. What kind of operations are you going to do? Are you doing over an image? Which website? Wycliffe, I think. Which website? Oh, this website isn't working. Let me just see. The
one you shared.
They pulled it down. I don't know why they pulled it down. They had all kinds of band combinations and indices. I don't know why they've removed different types of indices that can actually help, especially when somebody wants to do classification. It is good to add as many indices as possible. I'll show you even in my code I do that. So Hosea had spoke about reducers. So reducers in essence mean exactly just that. You are reducing something, let's say for example, let's say like what's the best thing that I can give as an example of a reducer? Like you see mean, the function for mean and median, actually what they do is they reduce. It's like you have a stack of cards, a stack of very many cards, and you want to do a per pixel operation on every single pixel. You want to do a mean or a median, a median for them. So you are reducing something from the way it was down, and there are different types of reducers. They actually have an entire section, unless they changed it. Yeah, they have an entire section on reducers, different types of reducers. Reducers that will work on images, reducers that will work on features. So you can see a feature collection. Okay, so what type of data sets does Google Earth Engine usually use? So there's an image, which you all know. I explained to you what an image collection is. There's a feature, and there's a feature collection. So a multi-polygon would be a feature collection. Yeah, but it depends. You can inspect. Remember that you can always print out the objects that you're using, so that you can be very sure that the codes that you're using for that specific feature are used with it. Because you might find you have a feature collection, but you want to work with it as a feature, and you have not filtered out a specific polygon. Like let's say, for example, you have Kenyan counties, all the counties within it, but then I wanted to do something over the region of Kenya, but I have a multi-polygon. Yeah, so there are different operations, there are different codes and methods that work with feature collections and features. Some of them are the same, but some of them are different. It's always good to print out and find out. If you're not sure, to find out what data set you have. Then, see what else. Okay, charts for charting. Let's see. Okay, let's continue this. So I was going to show you. It's just code that is also part of the example, part of this. Let me blow this up. 5. So I usually do these basic examples. I give these basic examples. Like this, I did the first time I created this tutorial was when I went to train WWF staff in Tanzania. So some of these things you'll find that I've used Tanzania a lot in the examples. So displaying an image, we'll apply a computation on an image. We'll apply a spatial reducer on the same image. We'll play with the bands, with different bands of the image. Then we'll calculate NDVI over the country of Tanzania. So displaying an image is as simple as this. Google Earth Engine has a command called map.addLayer. And then addLayer takes different parameters. It has the image. You can have an image. You can have a feature. This is how you add. This is how you display something. It does not necessarily. I think I need to change this. It's not necessarily just an image. I can also show a feature. I can also display a feature. addLayer can add a feature. So I want to add a layer. I'm adding a layer for SRTM, as you can see. And then I want pixel values I want values that are from minimum 0 to 3000, meaning something like Mount Kenya the top of Mount Kenya will not be seen because I have restricted, I only want heights up to 3000 meters. Yeah. So this is just displaying generally, but you can see, I think this is like Tanganyika. Oh, this is Tanganyika and this is Malawi. Yeah, so you can see the whole of this region, but we've not added any stylish things, but we're going to do that later on. Then how to apply computation. As you can see here, I told you that there are different filters, and remember that all these commands, all these methods that we're using, like image has a method called greater than. So I want to get all places that are greater than 2000 meters from SRTM. And then I want to get slope. So here I'm calculating slope for the whole region. And then I'm displaying first SRTM. I'm displaying the layer itself with a palette this time round. As you can see, I want to take from the range, like from 0 to 3000. We are giving it a command basically to go through the entire image, through all the pixel values between 0 and 3000, and then spread them to green, yellow, and brown. And then we are naming it at the end as DEM. All this, you don't need to cram them. All of those, all of these methods and objects, remember that they are all here. Within your docs, you have everything. Like let's say, for example, now this is image. You saw I did image.gt. GT means greater than. Let's see, GT. So you can see GT, this is greater than. GTE is greater than or equal to. All of these commands have been provided for us. Remember that you can just get them out here. You can look at different things. There are commands here that I have never used before. Yeah. There are so many things that someone can achieve with that. So let's continue from here. Whether this thing has to. Yeah. So where did they show the first one? This should be. Wish I'd written it all. Okay, so the first one, SRTM, is just I think that's the first layer that we're showing. Then high will be the slopes. High is just this. Then the slope. Remember, slope. I don't know why I did it all the way to 60%. I should have done it to 45. Okay, no, 60%. It's okay. So remember, slope is calculated. The slope is so this function here, terrain.slope. It takes an image. It takes the image which has altitude information, and then it calculates slope from it. Yeah. So what I'm showing here is this should just be the DEM itself. Let me see. Since there are only a few regions that have yellow, this must mean yes. This is the DEM. The DEM with the palette that I provided to it. As you can notice, I'm only showing pixels between 0 and 3000. And that's why it's spreading. It does not have very many places that are close to 3000. That's why you can see that yellow is spread in the middle sections. Then all the other places are low. They are very low. Yeah. And then applying a spatial reducer. So a spatial reducer would be like if you want to say you want to do mean or median over a certain region. Let's say, for example, you want to compare two forests. You want to compare two forests that have almost the same type of trees or fauna. They just have the same type of fauna, and then you want to see you want to get like the average NDVI over the entire region, over the two places. So you can use a reducer. Let's say, for example, okay, let me explain this in a simple way. You have a shapefile, and then you have an image, and then you want to see what is the average value within that image. Let's say within that shapefile over different times. Let's say like you want to compare the planting season or the harvesting season, or no, the middle phenological stages, like the growing season. You want to compare the growing season averagely in the past 10 years or in under 2 time steps. So that's a reducer. You go the shape this code here, the code that you can see on here. This code here, what I'm calling this dictionary. I don't know. I hope I printed it out. Yeah, it's there. So this part of this code, I'm taking the image, I'm reducing it over my shapefile, my polygon, whatever it is that I'm calling geometry. This is something I just drew. I did think I should have shown that part. I forget to show that part. In Google Earth Engine, you also have there's this part. I did not show you guys. You can draw shapes. You can draw shapes and save. Like, let's say, for example, whenever I'm creating data points, training sites, I usually just come, add the marker, create one, like a layer. Let me change it. So you see here, I can say I'm creating, let's say, maze. Yeah, I just want to collect that over maze. So it's a feature collection. Remember, I told you the difference between this. A geometry is like a feature, but there are different operations that work with geometries and features. Remember that all of these things have different methods. Some have the same, but some have different. So you have to remember. So like that, I don't want to add a property because I just want to collect it at the end of the day. Okay. Then I can go and add points and export it later on. I can either save it in my code or I can export it as a CSV because it's just a feature collection. Yeah. Let's see. So this part I should have shown this part. Yeah. Okay. Let's go on. So over a geometry, I just drew a box, just a rough polygon. Then I wanted to do min over it. So let me show you some things, some tricks that Google Earth Engine, some of the best parts, the tricks of using it whenever you stumble into problems. You can see here I did something called tile scale. So the tile scale means process my whole data in 2 parts. So you can apply. Let's assume you have a very large region. When you have a very large region and you want to do to do this reduced region, like you want to get some statistic from that part. Usually you find there are times when, for those who have used Google Earth Engine, you usually find stages where you get computational errors. This command for tile scale is very important. Just increase that number. Make it a safe bet would be, you can make it 16, or you can make it 8 or 16. I don't know whether it accepts 24 now. I don't know whether it does tile scale 24. But when you apply the processing that is being done at different segments over your geometry, or your let me call it shapefile. Let me just use the shapefile. Over your shapefile, it processes much faster. Maximum pixels is okay. Nowadays they increase it. Maximum pixels. There was a time when you had to specify this to allow it to process all the way to actually count to have all those pixels. Like, for example, if I'm doing something, if I want to do, like, let's say NDVI, I want to find the average NDVI for Africa. Let's assume I have one large shapefile that will cover all of Africa. I don't know whether nowadays that will. I'm going to try that. I'm not sure that. I don't know whether it will accept, because nowadays there are very many computational problems. But I can increase this. Okay, see now here there'll be very many pixels to be covered. There'll be more pixels to be covered within that processing than if I'm doing it for, let's say, an area like Kakamega. Yeah. So at times, okay, I usually specify this. For most of my code, I usually specify maximum pixels, but then it's not really necessary when I'm doing a small region. Yeah. I don't know whether they've increased the value, but this is the largest. That's 10 to the power 13. 1E13, yeah. 10 to the power 13. But at times there are areas where you have so many pixels and different pixels over every single band, and you usually get computational errors. Okay, so reduce region, I'm trying to do the mean over my geometry. You can see this is the geometry I drew, and on the console you can see it prints out. Like I told you, remember, it prints out here. So this is the mean, let's see, I was doing it for the STR. This is the mean elevation for this region. Yeah. And then, okay, then image bands. So an image collection, if you can remember what I said, an image collection is like a deck of cards. Think of a deck of cards whenever you hear about an image collection. Let's say, for example, here, this is the Landsat 8 collection 1, tier 1, real-time data, top of atmosphere reflectance. You can see that I've imported it here. I've imported it, the top part of the code. I can show you how easily that is done. Let me show you how easily that is done. For example, if you need an image like this ones, I imported all these images. If I need, let's say, let me think of a data set that's on there. Modis 6 or Modis 9. You know, Modis 6 GA. Yeah, let me take data of ocean reflectance. Okay, so this one is also okay. See, data ocean. There used to be a different one. It doesn't matter. Let me just pick any. So like this one, if I want to import it, I just click on here, I click on it, and then I click on import. Or alternatively, I can just click on import directly from searching for it. Like here, I can just click on import, and there you have the image collection for Modis has come in, and I can save it as a variable to manipulate it, to use it later on. So what does this essentially do? What do these parts usually do? Is that they have, it's like I have a deck of cards for all the images of Sentinel-2 since it started for the whole world. So the image collection has so we have some methods that you can do, you can employ on image collections. I should really know how to do that, how to change and open up that from exactly where I started. Okay, yeah. So as you can see here, I have the Landsat 8 image collection. And then from the Landsat 8 image collection, what do I want to do? There are things that I'm doing. Look, follow the variable, follow this variable L8. You can see what I do here is I have different options. I can filter date. This one I'm picking the whole of. This is a very long date range. From 2017 when it started to 2018 September 19th. And then I can filter bounds. So what I'm saying is from all that deck of cards, all of that deck of images, I want to reduce them to only the ones that are between these dates. And then I want to filter them only within the region where my shapefile covers. So now I will have a bunch of scenes. I'll have very many scenes over. I'll have a bunch of scenes over a small region. Yeah, then let me see, what do I do with it? Okay. So if you guys can remember what I mentioned about this, so you see here I'm just adding the shapefile. I'm displaying it on the screen. Then there's something that I want you to notice about these two. This line 10 and line 11. So filtered, as you can see, filtered is this variable. But then remember that when it's this filtered, what I've done is just I have a bunch of scenes. I have very many scenes over a small region. And you know, sometimes scenes don't. Let's assume you know that there's a path. Is it called SWAT or something? Okay, you know what the scenes are. All the scenes are tiled up in a specific manner, but your shapefile might not be tiled up in the same way. So, okay, what do you mean? Like, let's say for example, this laptop screen. The laptop screen is my region. Is a full scene, but then I have a shapefile that touches a little part of this scene and touches a little part of another scene and touches another part of another scene. So I will have 3 scenes for the same time step for that image alone. So when I display it here, this is going to produce it's going to have very many scenes appear at the same time. Yeah. So, and then line 11, median. Now you see what I've done. What I've done is I've taken all those scenes for that period of time, and then I aggregated them into median. So now I have an image. I no longer have a stack of scenes. Okay. Okay. Then let me explain this also. So, okay, this variable RGB visualization. This is just how I want the image to it's an option that I'm adding to, it's an add layer option. So it has the styling. I want only pixels between 0 and 0.3. And then I want to display bands in this order. I want band 4, band 3, then band 2. That is the normal. that the word? Normal composite? No. That visualization, it's that band combination is called natural color. Yeah, natural color visualization. Yeah. So as you can see, within my shapefile, I bet this should be the last one. This should be the last one alone, but something shows me. Do you see this part? Okay, that's really. I think this is a stack of scenes. This is a stack of very many scenes, but these codes, I remember I had them somewhere. Just confirm. I'll share the repository with all these codes for the lesson for the next time when we're doing the training, the practical bit. Yeah. Okay. But there, yeah, you can see I've displayed that a natural color, and then how to do band mathematics. So there are, like, for NDVI, there are two methods of doing it. I don't know that I've shown all of them. Okay, yeah, but that it's just okay. You can either do calculations this way. Let me see whether I did it in the different way. There are two ways of doing calculations. Let me show you within my script. So for NDVI, you can use, okay, this is one of the ways. They already have a function, a module, or to say, or a method that works with an image called normalized difference, where you just pass in the bands that you want it to calculate for you like that. But you can do the calculations by yourself manually. Let me show you within the guides. Okay, the guides have so many examples on that. I'll just show you in the script. Yeah, there's a place where I actually calculate some things down here. Okay, yeah, like you can see here, I have a bunch of indices that I want to calculate, not just NDVI. I want to be able to calculate something like MSAVI, that is a modified soil adjusted vegetation index, and then the soil adjusted vegetation index, and then I want to add EVI, enhanced vegetation index, and others. And if you guys find out about any other index that I did not know about, you can tell me. I love having tons of indices to whenever I want to do classification problems. Yeah, I like it when I really like it when the more the information I give to my algorithm, the more they're relevant, not just because there's something for guys who've done PCI. It's called PCI. Yeah, it's PCI. Especially guys using guys who've done okay. PCI is okay. It can be done on Python. It can be done on R. It's finding out the most relevant data set in a set of data set that you have. Let's say, for example, you might have a column. Think about having a spreadsheet, and then one of those columns has height, for example, and then another column has age. Averagely, we expect that people who are younger in age will definitely be short most of the time. Like, let's say if you picked a town, and then you are looking at that data. So PCI can scrutinize over all the other fields that you have and only tell you which ones are the most relevant for you to go and do your analysis with. But me, I love adding indices as much as possible. I just add all of them. So I said the most relevant. So here I'm picking different bands. I'm picking different bands.
Yes. Just a minor correction here. It was PCA, principal component analysis.
Yeah, PCA, not PCI. Yeah, PCA. Yeah, PCA. Yeah. So I do the calculation down here. So you see, there's this other way of doing doing calculations, and I prefer this one. Because I can write an equation. You can see like this entire equation. I can write equations, and then I'm just mapping them through this. Like, let's say, for example, now for NDVI, you can see in this since there's normalized difference, I would just pass into two bands. But for when I want to calculate the map expression, when I write an expression, so image.expression, and then I provide the expression. Then here, this is just a dictionary. Range bands is just a dictionary over which it goes to pick out the can I call them factors? Not factors. Can I call them variables? Maybe. Yeah, I can call them variables. I'm just picking out, like, let's say, for example, near infrared and red. When let's say, for example, if I'm doing something for Landsat 7, 5, or 4, through this dictionary, it will map out. It will take near infrared and red from this, then just carries out the calculation. So as you can see, like, if VI has a very long calculation, yeah. So that these are the two different ways of doing the same calculations. I prefer this one. With this one, you can do a lot of stuff. You can actually try and create. You can actually go and try and calculate to see whether you can have new indices. Let's say if you are doing a research paper, you want to show maybe the difference between turbid water and clear water. I think there's someone, I saw someone was doing something on that. So you can have your own experiment. You can write your own expression to see whether your classifier or whether your code is actually showing, okay, your code shows exactly where turbid water and stuff like that is. Yeah. So let's go back to this. Okay. Yeah, so we got the normalized difference. Okay, we are almost done. You need to know how to change that without starting the script from all over again. So I've shown you the different side, different way of doing that. You can do it by expressions, or you can do normalized difference like this. So this is the NDVI for the period of for an image. Remember, because now you see I'm filtering between 2017 and 2018, and then I'm filtering to the shapefile of Tanzania. Then I'm doing median, meaning I'm taking all that stack of images and I'm doing a median over them. So this is a pixel representation over. These are the median values for every pixel within that period of time. Yeah. Then let's see what else I do up here. I know I crop it. Interesting. Very interesting. I didn't crop it, but anyway, it's okay. We need to find out why this. Yeah, I should have clipped. Yeah. Okay. Yeah, I was right. If you can see on my comments, on the comments that I have down there on line 19 and line 21, these ones were meant for the class exercises. So later on, when there'll be exercises and stuff, and in the codes that I will share, in the repository that I will share, try and look at some of the comments that I make, because there are things that somebody's supposed to do. That's why you see here try running with ndvi.clip to Tanzania in line 17 above. That is what will clip out to this perfect shape of Tanzania. If I run it without specifying that clip, it's going to be amorphous. It's just going to be a bunch of scenes that are within the same region, but that have not been clipped. So it won't have this neat line that we can see around Tanzania. Okay, so this is one of the exercises that we usually do. I usually tell people to go and pick, to find a certain region, and then to do cloud cover removal. And then after cloud cover removal, they do something like NDVI, so for the first one. And then there's also a script where this links still work. I hope these links still work. I hope that link still has access to the same thing. Yes. Yes. All my assets went. I'm going to clear these ones out. Long time ago, when Google Earth Engine started, we used to save data in Fusion table as Fusion tables. Then later on, that's when this asset part had not been introduced. So this code, by the time I wrote it, I was still using Fusion tables. But I'll show you a different one. Yeah, I'll share a different one for this classification. So this is how it used to look like long time ago. Tambo when it was working. This is something. This was part of a hackathon that I did in Nepal. So we had just been taught Google Earth Engine, and then were expected to show something for it, and this was part of it. Something that we're doing with my team. We created something that can do classification. We created back then there was no that apps section. So this is something that we created to show how different classifiers on Google Earth Engine work against each other. Yeah. As you can see here, this one is running under what? But for an 82, I think this was random forest. This is this region was, what's the name of this region? It's a shapefile. It's a shapefile over. It's a shapefile over an area. I think this is like Kipia. Yeah, I think it's some region. It's some place where it's some region where we were investigating invasive species. So we had tons of data collected from a separate mobile application of where the invasive species were. So what we did was we just picked different classes and then ran the classification. Right now, back then, you see how this thing processed very quickly. Right now it has been having issues. I would have a computational memory error. Whenever you run into those, remember what I told you, that's when you're sampling, when you're doing a reduced region, increase your tile scale. And then there's something also, try and find out when people in America are awake. It's also some fun takeaway. Yeah, it's some funny takeaway, but it works. When people in the US are asleep, that means there are very few people that are using Google Earth Engine at that moment. Most of our scripts usually run well. But when you use Google Earth Engine when they're also awake, you find that you have most of those memory issues. I tried running this same script some while back. I think it was 2 years ago or something. I think 2 years, maybe 2-3 years ago. I tried running the same script and it crashed. It said I had a memory error. So something that processed at one time, because during this time I think there were less than 100 users on Google Earth Engine by the time me and my team did this work. Yeah. And then I'll show you something about the widgets. You notice on here, I hope this one works also. I really hope this one's work. Oh, it's here. The outer one. Okay. So I hope this one still works. Let me just see. Yeah, it works. It's okay. So how to add these widgets? How to add some of these widgets? You can see the slider. You can see this is a date picker. I think it's a date picker. If I'm not wrong. All these things are on. There's an entire section for these widgets. Let me show you under the user guides. There's an entire section. Why did they remove it? No. Yeah, it's here. Widgets, layouts, and other stuff. They have an entire section of how to add them. How to add a button. It's just this simple code. But don't print it. Yeah. There's a command. You can add it. You can add it to a layout. So yeah, we usually don't print. Like most of these things, when you look through this code, where is it? I don't find it. When you look at this, you can see that there. I've created a panel, and see I create a panel, and that is also mentioned here. So I add these things to that panel. Did I add them? I added them somewhere. That's why I'm creating all the widgets. Yeah, and then panel.add. So I'm adding them within that. Yeah. Yeah. So there's different kinds. There are checkboxes, as you can see, sliders, date sliders, text box. If you want to insert, like for example, if you want to create an app where somebody does not have access to the code, but then they want to process something that is sitting in their assets, then you can have a text box, and then they can fill it with the link to the asset, to the object in the asset, and then they use it. Which, before I forget, there's something that is very important I have to mention. So in the assets, whenever you add something in your asset, there are two things that you have to remember. This thing it's private to you. It's accessible privately only to you. If you want to make it accessible with other people, you share. Let me show you what to say. You share. Then on here you can click on this. That's for people who have those challenges. Here you can see something. You can see it has been written. Anyone can read. So if it's like this, only Steve can access it. If I add someone, let's say for example, I might be able to add like Brian. I can add Brian's email, and then I make him a reader. Brian can access that thing. Brian can change some parts of that same of that data set. But what I usually do is, because most of the work we do is open, like it's usually open. So most of my data sets, since I've also gotten them from sources that actually share them, I usually just make them that anyone can read. So then now this way, if I share my script with you, you won't have problems accessing that this Rwanda's district within your code. Yeah. So they're different. There's a select. This select is like the combo box, the drop down. You can add a chart. I will show you an example for charting, and then there's thumbnails. So I don't know whether right now they do it differently, but a long time ago we could run videos through these thumbnails. I still think it works. Okay. Thumbnails, then the map section. A layer is within a panel. Within a panel you can have layers to store. Okay, you can have a panel and a panel. How is the best way of explaining this? Layer. No. I was confusing panel and layer. The layer is just what you display by the end of the day. It's what is shown whenever you display something here. You see all this. Let me show you here. Here, this is the layer that is being displayed. The layer that is actually being displayed down here. Anything that you add, map.add layer, all those are layers. Yeah. I don't know why they put it under widgets. It's not a widget. Okay, it might be. No, it's not. I haven't used this before because I am yet to register, yet to use my credit card and then access the cloud, access Google Cloud services. But I will soon. These drawing tools are these ones here. As you can see, you can opt to remove them so that they don't get shown within your script, or you can add them or change where they are, their position. Yeah. That's just a layer. A linker, link and split panel. I think, let me show you those styling widgets. Okay. A linker. Did I do one project where I use a linker? Yes, I think I did. So let me see. Bearland. Distribution of this Bearland and VA thresholder. Just see. Did I have split screen on this one? No, there's a widget, so there might be. See, run it. Let's see, is this really? No, this one does not have. This one did not have the. Let me see. CCDC. Split. Split.
Oh, and Steve, we've got 10 minutes.
Yes.
Just let you know.
Oh, I just want to show you this thing. I just want to show you one of these things. I'm sorry, let me not take so much time because most of it. Okay, let me show you even this one. So this one I've just gotten it under. This is what all of you have. Remember examples. I told you examples part is very important. So under examples, there's some. They have a section called user interface. So under user interface, I've just picked the split panel and show you what they do and the linkers do. So this is what. Let's see at these dates. Okay. So now this was what was this person trying to do? So confirm. What data set is this? This is Sentinel-1. Sentinel-1, what did they want to do? I think they were looking at a river. They're looking at the swelling of this river. Do you see this river that passes here? So there's a time when this river flooded, as you can see. So this is the split panel. And then the linker also works here. It links both sides of the screen. So you can see when it flooded on. Actually, these two images are only 7 days apart. This is 2018, 2018, July 21st. So between 21st and 28th, this river flooded, and you can see what happens. Yeah. And then, let's see, is there anything else? And then how to style them. You style them like just CSS. Yeah. Normal, ordinary CSS. See, where was I? Did this? We have done that. We've done that. Let me see. Oh. Isn't it opening? It's not opening. It's working. Isn't my show? Here we go. So I've done that. I've shown that. I've shown the widgets. This is just an example. It's the example which I opened just recently. Then this will be able to do this later on. This was an exercise. Yeah, I hope this still works. I'm hoping this still works. Let me see. Yeah, this still works. It's okay, but the data set. Yeah, because the data set. Okay, this still works. So that link is there. You guys can have a go and play with this. and look at how I did a very simple. Okay, this would show you most of that code that is inside. You'll find out how to add these drop downs, this select tool, select widgets, how to add labels, how to style different things like fonts and stuff, how to run, how to process. Like if you want to export something, what type of code segment you need in your code. What code segment exports something if you want to get it on your drive. And then let's see. Then I asked them to. I asked the students to use the same tool, modify it, and then run a classification of something else within their region. And there we are at the end. But there's still much more that this is just for the beginner level. So you might wonder what is there in the intermediate and or in the advanced level. In the advanced level, as you can see down here, there are other things that you can do. Like let's say, for example, an intermediate or somebody who's at the advanced level might be doing specific studies for specific things. Let's say, for example, somebody who only deals with Sentinel-1 data, they might want to know a specific application. Let's say, for example, they want to look at canopies. Yeah, so that's what we do within the intermediate. In the advanced level, what I would show you is this part. This is the most recent addition to what Google Earth Engine has. This part, this machine learning section. I even remember when the guy who wrote this is called Nicholas Clinton. I remember when he did this, he showed me this part. He showed me that it's going to include this part before it was out officially. Yeah, but this is where now the real power of Google Earth Engine actually comes in. You can run. Remember? Like the other day, I tried to run something. I tried to write. Okay, I wrote some code that can predict lines from what it has. Some model that can predict lines from what it has seen before. Let's say, for example, you want to give a description of some street, some place. Then you just know it vividly. You know the way people usually don't know how to. Somebody will tell you, it's next to some red building. I don't know, something like that. So I wrote some code which takes has learned on corpus of text, and then it can produce. So I tried to do the same with the Bible. And I'm telling you, my friends, my laptop could not process just NumPy, a simple NumPy operation. My laptop could not take in the corpus text of the entire Bible. I had to run it with only one book. I only ran it with Genesis. So Google Earth Engine, now, in this case, you'll be processing something within their servers. And that is the advantage. You can actually run a machine learning model in a very short time over something that would have taken a very long time on a machine like, let's say, like mine. Yeah. So this is what we will do at the advanced level. Something else that I have to add also, take note that Google Earth Engine, you can write this code. Okay, within the code editor. Within the code editor, you write JavaScript, but then you can also write the same code in Python. Let me show you examples. Is that my? Let me show you just a simple example. The things that you have to remember with Python is just the Pythonic rules. You lose the var. You lose the semicolon. You just write it as though you are writing. You write it the same way you would write. You'd write Python code, but then there are some small changes. Yeah, but it's not that bad. Yeah, it's not that hard to transform. Let me see whether I can open one in my drive. Let me just see. Drive. I think I've seen it somewhere. Drive. Let's look through machine learning projects, the most recent ones. This one for crops. This one's for TensorFlow. Okay, this one. So it's just I'm doing it on Colab. It's easier to process those things on Colab. Yeah. So install Gmap. Gmap is it's a okay long time before we had a different code. We had a different module to display things on Python on the Python environment. Nowadays we use this Gmap. Then you need to authenticate, and so as you can see here, I'm importing stuff. This is Google Earth Engine code. You notice that now the way I'm writing dictionaries might be. I think it's the same. The way I'm writing a dictionary here is just the same as the other side, but then no semicolons and stuff. My expressions, you remember I told you when I did the expression, now this is the way we'll write it here. Now you notice that on here we don't have, I did not add this, let me just show you what I mean. Expression, let me see, one of them, when there are things, there are very tiny differences between how you write it in Python and how you write the same things in JavaScript. But they have, if you're having problems in transitioning, they have a whole section. They have a whole section where they explain what are the okay, they used to have one. The other part, I think it's out of this Python installation. They have a section where they have written what are the things you do in what's the takeaway for when you want to transform to start using Python to do these things. Yeah. So like in the previous one, I wrote the word expression somewhere around here, and then I wrote something here. I wrote map here. Now there's no need for map. It's not used in this side. The function for cloud masking. You can see the way it's just the same. There's no difference. Image.update mask. These are the same functions that run under the hood of Google Earth Engine. Yeah, so you can do things in this. You can decide to do Google Earth Engine completely outside the code editor environment if you want to use Python like this. Or I also had some guys who have found a way of linking Node.js. So if you're a Node developer, you can also use Google Earth Engine with it. And then I guess that's mostly it. So remember that this section here of the section of machine learning, this would be for the advanced level. Yeah, but anyone can do it. You can just go and read through it. So far, we've found out that random forest outperforms most, which is weird. But random forest has been outperforming neural networks in image classification. Yeah, it's just something. There are people who are writing papers on it, but you can experiment with stuff. This is relatively new. This is still relatively new, and you guys can go ahead and get started with it if you want to. If you can do it, maybe in a different day, on a different Sunday. We'll discuss with Brian and pick the best time for that. Yeah, so with that, we are done. I want to look at any questions. Okay, let me look from the top. Yeah. What was there says is true. Yeah, this website, I'll try and find it. Okay, someone found it. I hope it's the one. Yes, this is what I was searching for. This is what I was searching for. This is where I got most of the information of these ones. But there's also another one that has also indices. I've forgotten about. I don't think I wrote that one down. Okay, and then okay. Machine learning on the assets. Can support audio file.